Hello and welcome to a special edition of Issues of the Moment. This edition is a special one because it is not coming to you from our usual studio setting. Instead, we are on location in Nairobi, Kenya, at a high-level continental meeting focused on the future of agriculture and innovation in Africa. Here in Nairobi, stakeholders from across the continent have gathered for the validation of outcomes, workshop of the genome editing landscape analysis exercise, an initiative led by the African Union Development Agency, New Partnership for Africa's Development, AUDA-NEPAD. The exercise spans 16 African member states and seeks to take stock of how genome editing is shaping research, policy, and development pathway across the continent. Now, genome editing is increasingly seen as a transformative biotechnology with the potential to address some of Africa's most persistent challenges: low agricultural productivity, climate vulnerability, food and nutrition insecurity, and limited innovation capacity. Yet, despite growing interest and activity, information on genome editing research, infrastructure, policy frameworks, and institutional capacity across Africa remains fragmented. This validation workshop is therefore a critical step, bringing member states, researchers, and policymakers together to verify findings, consolidate data, and build ownership of a shared continental narrative on genome editing and its role in sustainable development. Joining us at this important moment is Dr. Bongani Nkabinza, an experienced researcher affiliated with the Directorate of Agriculture, Food Security and Environmental Sustainability at AUDA-NEPAD. My name is Justin Bemui and I welcome you to this special edition of the program. Stay tuned as we take a breather here. Once again, thank you so much for joining us on Issues of the Moment. This is a special edition, coming to you from Nairobi, Kenya. And our focus today is on genome editing in Africa, validating pathways for food security, innovation, and sustainable development. My guest today is Dr. Bongani Nkabinza, a researcher with the Directorate of Agriculture, Food Security and Environment Sustainability at AUDA-NEPAD. Well, thank you so much for finding time to join us on the program Issues of the Moment.
Thank you, Justin. It's an honor, my brother.
You're welcome. You're very much welcome.
Yeah, thank you.
Let's start. Why is genome editing increasingly important for Africa's agriculture? Food security and broader development agenda.
Yes, Justin, I'm sure you might be aware that Africa as a continent, we are faced with a lot of adverse challenges, especially in the agricultural productions in the agriculture sector. These include high infestation of pests and diseases, adverse climate conditions, and so on, which using the conventional agricultural practices and agricultural husbandry, we have been able to have a resilient agricultural production system, but recently it's starting to hit a decline. So it's affecting the food production in the continent, in the different African member states. And the only solution is trying to keep up with the technological agricultural transformation, which genome editing is among the tools that have a prospects of increasing, addressing those situations, those adverse challenges, and increasing agricultural productivity in the continent and in the various African member states.
Now, let's coming from that angle. we have a workshop here about validating, the genome editing landscape across the 16 African member states who are, partaking in this, the development of this technology.
Yes.
Why is validation such a critical step in this process?
Okay. I'll take you a step back to 2023, where the same stakeholders met in Accra, Ghana, to come up with the terms of references upon realizing that the continent is actually being affected by fragmented data, and also effects of the left hand knowing what the right hand is doing. So after that, the order NEPAD then engaged a consultant who then conduct a deep dive assessment of the genome editing situation in the continent. That was especially upon seeing that a number of member states in the continent have started adopting the technology, but we had no record of what's happening, where is it happening, what are the capabilities in the member states, what are capacities that are existing, how are the infrastructures in the different member states. So we needed to get a picture of what is happening. So the consultant was able to gather that information, come up with those reports, and as Order NEPAD, we are at the service of member states, so we had to bring back the products to the member states for them to verify and acknowledge that indeed what is on the reports reflects the true picture of what is in the member states. The data collected is truly depictive of the real situation that is happening back home. And just to mention, so far this landscape analysis has been done in 16 pilot countries. I'm sure you are aware that in the continent we have 55 member states. So we are hoping to treat this phase as the pilot phase, and we're hoping to engage further and continue with the exercise going forward to the other member states.
Now the landscape analysis has been done.
Yes.
If I may ask, what are the trends, that are emerging from this landscape analysis in terms of research capacity, infrastructure, and institutional, readiness to adopt this technology?
Just to name a few countries like Ghana, Nigeria, Kenya, Ethiopia, and Malawi. Those countries have adopted the genome editing guidelines, which means now genome editing is in their regulatory frameworks. And having mentioned those 5 countries, it's worth mentioning also that looking at the trends, they seem to be at different stages of research and development with regard to genome editing. For instance, countries like Kenya, they are already having crops like sorghum at advanced research stages. Countries like Ethiopia, they already have teff at trial stages, that is African bred or African produced genome editing sorghum and teff. So it's a technology produced by Africans in Africa for Africans to solve African challenges.
Now, talking about African challenges,
yes, sir.
Give us a breakdown. How can this genome editing technology or biotechnology, help African countries, build resilience against climate change, pests and diseases, which are the challenges, some of the challenges you rightly pointed out?
Yeah, okay. I'll take you back to the earlier parts of our conversation, where I mentioned that as the continent, we are faced with a number of adverse challenges. I'll make an instance of pest diseases like viral infections. Viral infections, they infect a particular plant, and they establish the viral DNA establishes itself inside the DNA of that particular plant. Maybe pawpaw, maybe maize, or any plant. So genome editing enables scientists to mimic natural mutation by specifically removing the viral DNA in the plant.
Okay.
So that way the plant will not be affected by that viral infection. That is an example of coming up with plants that will resist pests and diseases, agricultural pests and diseases, that can still be applied in animal cells. Then the second part, when it comes to adverse conditions like drought, adverse weathers, the main effect on the plant is the susceptibility genes. If the plant is susceptible, then it won't survive those situations. But scientists have a way of mimicking still the natural mutation in a very precise and targeted way, and remove that susceptibility gene with no any other effects on the plant. So that particular plant will then be able to withstand drought conditions, or will be having increased water use efficiencies or nutrient use efficiencies. So in that way, the science of modern biotechnology, which genome editing is a tool, or it's part of, it assists the societies in improving their crops in a way that is similar to natural breeding. But this way, it's at a faster pace, at a more specific pace, at targeted precision, high precision. We know that we are only targeting this particular gene, and we are removing this particular gene.
I take you up from there. Before we go further,
yes,
you said this is close to natural breeding.
Not even close. It's similar.
Similar to natural breeding.
Similar.
Okay, now I want you to bring it bare.
Yeah.
Now draw a line between gene editing and genetically modified organisms, which has been some kind of a critical topic that has been agitated in some quarters by so many people. What is the difference? This is an emerging technology, gene editing.
Yes.
What is the draw the lines? Let's see what's the difference to the layman out there.
Yes.
Let's make it relatable.
Okay. First, it's worth mentioning that genetic modification and genome editing are two totally different tools that fall under modern biotechnology. So I'll start off with genetic modification. In genetic modification, a gene is discovered in another organism to be, I'll make an example, to resist worm attack or lepidopteran attack. In maize, there's in cotton, there's bollworm. So that gene is discovered in another organism to be resisting bollworm attack. So it's taken from that organism and inserted into the DNA of this particular organism. Let's say this particular organism is the cotton. So the cotton with that gene that has been taken in another organism, now the cotton will be able to withstand bollworms. So in short, in genetic modification, there's the addition of a foreign genetic material from another organism into this organism.
Okay.
So having explained this part, now we get to the next part, to genome editing. Earlier on I mentioned that genome editing, it mimics the natural, it's similar to the natural breeding ways or natural mutation. In mutation, and it's specific, genome editing, you don't add any foreign genetic material from any organism. You just identify the weak links, the weakest genes or the susceptible genes within, or the affected genes, if it's a viral gene, within the DNA of this particular organism, and then you in a way silence that gene, or you remove that gene from the DNA of that particular animal. So in that way, if ever this plant is susceptible to a particular virus, or it has the viral DNA, you just remove only and specifically the viral DNA. And if I can take you back, naturally we do have mutations happening. In mutations, it's where maybe the genetic material is either deleted, or there's natural insertion of genetic material into the DNA, or the DNA it gets inverted, but it happens naturally within the plant. Is that just that natural mutation happens at a very, very, very low frequency? Maybe one happens after 20 years. For instance, the transition or the production of yellow maize, it got through natural mutation from white maize. It happened naturally. Boom, there's now yellow maize. The genetic material of that particular plant changed only for that specific characteristic. So genome editing does not involve any foreign genetic material. It's just the genetic material that is specifically targeted and modified from the plant to make the plant have a superior characteristic. So we are enhancing or imposing a mutation that might have otherwise occurred naturally into the plant. That's why there's the strict separation between the two. In this part, there's foreign genetic material that is added into the plant's DNA. In this part is the plant's DNA, just that you identify the weakest gene, the weakling genes, and either you silence them, you remove them, or you just modify them.
So in this case, the fears, the criticisms, and of course that are associated with GMOs does not count when it comes to genetic editing, because it is what you're saying now. Does it mean this is 100% safe compared to what GMOs, the stories behind GMOs?
Even though GMOs are still safe, because before they are even released to be used or to be commercialized, they undergo strict risk assessment processes. They don't just from the lab, boom, straight to the market. So they are seen if ever there are any toxicities before they're even released. So without putting any doubt on genetically modified organisms, on this side, genome editing products, the processes of getting the final product are totally different. Yes, so there's totally, like I said, this one mimics, is similar to the natural process.
Breeding, okay.
So there's totally no fears that can be anticipated or anything.
So with this, now how does, science-based policy, regulatory frameworks, how do they come in to enable responsible adoption of this genome editing technology?
We take a step back to, I think it's 2004 or 90 something, where there was the establishment of the Convention on Biological Diversity, which aims at protecting the environment, conserving genetic materials, and so on. And it has Article 8G, which mentions that genetic modern biotechnology processes should be regulated. And these should be regulated through a separate instrument. That's why the United Nations and its parties to the convention, they then came up with the Cartagena Protocol, which was then a specific regulatory tool that regulates not genetically, that regulates modern biotechnology products and modern biotechnology by only focusing on the transboundary movement.
Okay.
So it regulates transboundary movement. Whatever you produce in your country, we should have agreed before it even crosses into our country. Then different countries are then obligated to domesticate the Cartagena Protocol into their national legislations, which enable them to operate and to customize it to their liking. And that domesticated protocol, once it's domesticated, it's then domesticated into national legislation. Most countries, they are having biosafety acts which are regulating the technology.
Okay.
Yes.
Before we go, how can AUD and NEPAD, use the outcomes of this validation exercise, to strengthen continental collaboration on biotechnology, not just genome editing or other things, but emerging technologies in biotechnology?
Justin. Nowadays, we are living in the era of data. Anything you do, any decision you make, you must have information. Before you get dressed in the morning, you take your phone and look at the weather. And you know that, oh, okay, it's going to be warm today. So you take your decision. So this landscape analysis, it's earlier on I mentioned that data in the continent is fragmented.
Yes.
We didn't know what's where, what's been done where, what capacities are existing, anything. So it's difficult to even coordinate. Let's say we are different member states. It's difficult to even coordinate by doing the same research or collaborating in a single research. Otherwise, instead we find ourselves even duplicating. We are doing the same research, I'm doing the same research, and we are duplicating effort. That is, we are not putting our resources into good use, just only because I don't know what's happening in your country. I don't know what's happening. You don't know what's happening in my country. So this study will consolidate the data or the information that there is across the continent, which will assist in enabling in coming up with informed decisions. Number two, in strategizing resources or fundings that are available for the continent, and also to support policy formulation. Policy formulation leads to the previous discussion of the regulatory mechanisms. So once we formulate an enabling policy, we are able to regulate whatever needs to be regulated, especially the genetic modification technology. We are able to regulate. We are able to see if, okay, this does not need to be regulated. There's no need to frustrate the researchers. There's no need to hold back. There's a term that is being used, was used by one of the regulators, that African farmers, because of the fear that is being instilled through the myths that are coming out of nowhere, they are in actual fact held back with respect to food security availability or food availability. So in countries where there's been no enabling policies, they still do not have access to the technology. It would be a violation of the law to use the technology when the law is not there or when the law is not enabling. So the reason behind having this landscape analysis is to have enough information to guide in decision making, to guide in strategizing investments, and to guide in policy formulation.
Now, let's have a goal to talk about. Just maybe in 30 seconds so that we round up. Now, looking ahead with this exercise you just talked about, maybe the findings, what would success look like, maybe let's say 5 years from now, if African countries effectively implement the findings of this exercise?
Can I start off with an example?
Yes, sure, you can.
Let's say we are having a donor who wants to assist to establish a research facility. If we don't know what you are doing, your status, your stage or your trends, and you don't know mine as well, we'll both be seeking the same funding to establish that facility in my country and in your country. Yet now we know the status. If, let's say, you are at an advanced stage of genome editing research, it's better to ensure collaboration. Usually they talk of South-South collaborations, so that I can use your lab, I can use some of your expertise and not work on reinventing the wheel. So those collaborations we easily get to the desired target. So once we are at the stage of commercializing this genome editing products, imagine if you are having maize that is able to withstand drought situations. You are having cotton that is able to withstand bollworm infestation. Ultimately, that translates to less losses to the farmers, which in turn that is high productivity to the farmers. So what is the agenda of the continent? Agenda 2063. We are aiming at ensuring food security and transforming the economic status of all the farmers in the continent. Yes.
Well, thank you so much. I really appreciate your time with us on the program. I can't thank you enough.
It's been a pleasure, my brother. It's been a pleasure, my brother. Thank you.
You're very much welcome. Thank you so much.
Yes, sir.
Now, thank you for, genome editing represents an opportunity, or both an opportunity and a responsibility for Africa. An opportunity to strengthen food security, build climate resilience, and drive innovation. And a responsibility to ensure that science, policy, and public trust advance together. This validation workshop in Nairobi highlights the importance of evidence-based decision-making, regional cooperation, and strong institutional ownership in shaping Africa's biotechnology in the future. Now, thank you so much for joining us on the program on this special edition of Issues of the Moment. Until next time, we will continue to examine issues shaping Africa's development and pursue solutions that move the continent forward. This is where we end the program. My name is Justin Bemui, and I say bye for now.